This is my week two check-in for engineering 2030. Uh, Checkpoint number one, time spent studying. This week we went over chapter 11, and so spent about 3 hours on videos. I know there's only about 2 hours in total, but I ended up rewatching quite a bit, just going over everything, rewinding. And I spent about 4 to 5 hours on the homework, which included going over the chapter in the textbook as well, looking for guidance. Videos watched. I watched all the chapter 11 videos on YouTube up to the example number 9 video, or at least started all of them, but didn't. Depending on what I was stuck on with the homework, I was looking for help with certain things, so that's kind of why I went to the textbook. Then homework problems completed, chapter 11, homework 1 through 14. Basically, we go over this later again, but we're pretty much just dealing with different rates of change. See there, v is equal to v dx over dt. Just using different velocity equations that are given, or different. Number one deals with you're given a position function. Here we have a velocity function where we have a initial velocity and then just a relation. And then just among many different problems, you end up doing very similar integrations no matter what. Maybe we have a guy dropping a bowling ball off a boat, and it ends up being very similar to somebody running track. Then we also did quite a bit with, I guess, radial accelerations or tangent accelerations as well. And I guess that's actually not this problem, but we do deal with radiuses here. One big staple was learning how to manipulate things so that we don't always have functions in terms of certain variables, but we know dr over dt is equal to v, and then but we do have the velocity in terms of r, so we can use that to our advantage and do integrals that way to account for everything, like there. I'll just follow the line down. Then we covered a few geometric constraints as well. Like this guy here, number 6, and I believe number 14. Just using different, well, first you have to set up which ways are positive. So we have our x at point A, how far the rope is moving there. We know the length is constant between that part and this part. I'm going to explain this in the chapter 11 homework video, but yeah, but using different reference points. So we measure y compared to from there to there, and we have x from there to there, because nothing is moving in the x direction over there. So that was pretty interesting. Maybe now length is constant, so we could determine velocity and acceleration, or at least use some equations to help determine those. And then also learning how to use graphs to determine change in position, just as a visual thing, where area under the curve, so all that stuff is equal to this change right there. We also have just three-dimensional things again. Everything kind of stems from rates of change and manipulating them into x and y components, as you can see there, initial velocity in the x and initial velocity in the y. And then, and very similar here, or if we can group unknowns together. That was kind of a big part of number 10, so that you can solve for, you have two unknowns, but if they're multiplied together, they create one unknown, and then it allows you to find an unknown, one of those two unknowns later on down the road. And I said, kind of radial accelerations, which is the normal or tangent path. So normal force going in, tangent force kind of is going in a straight line from where it's straight out. I mean, they're always separated by 90 degrees, but we now know tangent acceleration, so that can go to zero, and then so we just have a normal acceleration. And same thing there, but just finding the radius, or the instantaneous radius of curvature. This is where I've struggled the most. Number 13. I know in the slideshow I'm not sure why I didn't do it before or while looking over the homework, but I need to go over radial accelerations again. See it right here, review physics, chapter 12, rotational dynamics, and just trying to understand this part right here and how all of that is related better. I think I have an understanding in my head of it, but still, I'm not quite comfortable with it. And here we just have another geometric constraint as before. So that was homework completed. Other efforts that I did, found group for the project. That's kind of a big one. Just sent out a mass message looking for other people. Got, I don't know, lots and lots of responses from people. Thankfully, fairly quickly, so I didn't have to stress. But uh, obviously, maybe not obviously, but I got more than two people to respond to me. So I just tried to help people link up if they could. I just kept sending messages to people, or if people messaged me, I'd say, "Oh well, I'll send people your way," or "This person has contacted me. They're looking for a group as well." Just I'd send a message to them. But I don't have it on hand, but I purchased might be butchering this, my anemometer for the project as well. So that's cool. And summary of the material learned, all about rates of change and manipulating what we need to do, or manipulating what we have to find what we want. Like, we know acceleration, and I should put that there. Acceleration is equal to dv over dt, but we might not have everything in terms of time. So we we know dx over dt. So we know this can end up with dv over dx with respect to dx times v, because dx over dt equals v. And then this all equals acceleration. So I had never really thought about that before, but it does make sense, and you can do different integrals with it as well. So that's very useful. Just going over different coordinate systems, normal, tangent, polar. Yes, Cartesian is in there as well, but that's something we're all very probably most familiar with. Geometric constraints is kind of a big one, as I showed earlier. Homework problems number 6 and 14. It's very interesting to see. I mean, you can define your positive values anywhere, or which way is positive. And then I believe it's planar motion, or just that rotational dynamics, as I have written right there, is something that I need to continue to go over, because that part's a little confusing for me at the moment. So I know I can get there. I just have to do it. But yeah, that's pretty much everything I've done in the past week. Uh, we have the Chapter 11 quiz coming up in 2 days, so I know I need to work and study more for that to be prepared, but that's what I did. I know for homework time, it seems a little long, but I definitely took my time, multiple sittings, just kind of going through, trying to understand everything. And yeah.